Hello and welcome to my channel. So today let's look at the Q2 of contest of yesterday. The question 2139, minimum moves to reach target score. So the question is you are playing a game with the integers. You start with the integer 1 and you want to reach the integer target. So we just need to go from 1 to target. And in each move we can increment or double, and you can use the increment operation any number of times. However, you can only use the double operation. Double can only be used like a k times. We can change the input as to k. So save some typing. So given the two integers target and k, return the minimum number of moves needed to reach target starting with 1. So example, target 5 max double is 0, so we can only increment because we cannot double. So it will be 4. And example 2, 19 and max double is 2. So we increment 3 times to 4, then double once to 8, then increment once again to 9, and double again to 18, then increment another time, so to 19. So the example 3, target 10, max double is 4. So we increment once and double once, and increment once and double once again. So in this example, we didn't use all the 4 doubles, we only did 2 doubles. So but still we have the minimum number of moves. So the constraint, the target is between 1 and 10 to the power of 9. Max doubles is between 0 and 100. So I actually I didn't do very fast in the contest because I'm trying something wrong. Some approach. I thought it's a BFS question, breadth first search, because I saw the return the minimum number of moves needed to reach target. But the problem of BFS is I implemented the BFS and it passed all the examples. But then I got a TLE, time limit exceeded. Also, we can see that the target between 1 and 10 to the power of 9. So it's possible BFS will need to have 10 to the power of 9 steps if the test case is constructed that, so it will definitely cause TLE because the Leetcode only allow 10 to the power of 6, around the 6 to 10 to the power of 7. So if your computation require more than this number of steps, like then it will cause the TLE. So then I'm thinking that how do I solve this question? So we have to use some greedy approach. So also the officials like I think most people's solution is using greedy. So the firstly we have we're starting from 1, right? But we go to the target. But there's another way of thinking is we can go from the target and we see how many steps we go to 1 by using half and decrement. So this two ways should be equivalent. Then we just find the minimum number of steps to reach 1. Um, so, but for target to do half, we actually, if the target is not a multiple 2, we can only decrement. So this step we will only do decrement because it's not a multiple of 2. Otherwise, we can select either decrement. Else, we need to choose between half or decrement. So there is another constraint of this question is it has max doubles. It only allows k half operations if we do reversely, right? Or maybe k double if we do in original direction. So assume we have k doubles, then should we do the double earlier in the process, or we should do double later in the process when we do in the original direction? So if we have 1, we double to 2, right? Then we only increase the 1 in this situation. But if we so increase the 1, then we increase 1 again. Then we get 3. Another possibility is if we increment 1 firstly, we get 2, right? Then we do a double. So we get 4. So actually we increase the in the first example we increase the 3 minus 1 equal to 2. But in the second example, we increase the 4 minus 1 equal to 3. So from this, we can see that we need to do the double later. If we don't have enough double, we don't have enough k. So then when we do the reversely, we need to do the half firstly, which means when we go from target to 1. So this almost explains the key of this question is we need to do half as early as possible. So as long as we find that the target is a multiple of 2, we can do half. And also there is another constraint is we still have enough half operations left. So now we actually can we almost are able to solve this question. So it's we can use the greedy and then do the from target to 1. So we need to have a count, right? Count of operations, like or we call the steps, count of steps. So then Yeah, we can keep another count which is uh actually we don't need that. We can actually just decrement the k. So one target while target is larger than 1 and the k is larger than 0. So if target is a multiple of 0, multiple of 2, then we can do target divided by 2. Then here we do count plus plus. Otherwise, we do target minus minus. So both are count plus plus. So so we increment count in both situations. So then after this is done, then um, after this is done, either target is 1 or k is 0. So if target is so actually we don't we cannot we don't need to we just can target minus 1. See how many steps left. Those steps are all doing the decrement. So in the end, we only have decrement operations after after the double, like half is done is completed. Um, so we just return count here. Oh, there's one thing actually I didn't forgot one step is k minus minus. So whenever we do a half, we need to decrement the k, so that we have one less half operation left. So let's do 19. Okay, so this is correct. Yep. So the um so this is example of a greedy approach to solve the Q2 of the contest. So if you have any questions, let me know, and or I will try to answer in the comment. Thank you for watching. See you next time.